On the path toward mastering the skies and commanding large airliners, every pilot must first undergo training in small instructional aircraft, machines often referred to as classrooms in the sky. It is in these training planes that, for decades, countless future aviators have first learned the fundamental principles of flight. But as we will see today, even within the flight school environment, students are not immune to danger, nor to a chain of human errors that aviation can never forgive. November 7, 2012. At the Sassevo Civil Aviation Flying School in Russia, one of the most tragic accidents in the institution's history occurred. Today's investigation will help us uncover how a series of technical malfunctions and human decisions led to irreversible consequences. The incident took place at Pazhanaji Airfield, located in the Ryazan region. Students of the Sassevo Civil Aviation School were carrying out standard training flights. These flights were designed to help cadets master practical aircraft handling skills, perform various maneuvers, and learn how to react under abnormal or emergency conditions, all under the supervision of experienced instructors. On November 7, 2012, the Yak-18T training aircraft was crewed by two pilots with vastly different levels of experience. The instructor pilot, Vladimir Mushutz, was a graduate of the Krasnodar Military Aviation School. He had flown 105 hours on the L-39 jet trainer and 100 hours on the Tu-134. After graduation, he served 4 years in the military, acting as co-pilot on the Tu-22M-3 supersonic bomber, accumulating 156 flight hours. When the military reduced personnel, he left the service and in 2010 moved to Sassevo to work as a flight instructor at the local civil aviation school. By the time of the accident, Mushutz had logged 887 total flight hours, over 430 of them on the Yak-18T and AN-2 aircraft. He had never been involved in any previous incident. However, investigators later found that his commercial pilot license had been issued in violation of federal aviation regulations. According to the rules, a commercial pilot must have at least 200 total flight hours, including 100 hours as pilot in command. While Mushutz met the total hour requirement, he lacked sufficient captain flight time. The investigation also revealed numerous irregularities and omissions in the instructor certification records and flight documentation processes at the school. The student pilot was Dmitry Fedorov. In 2010, he had first enrolled at another school to study automated control systems, but in 2011, after passing exams and selection tests, he was admitted to Sassevo's program in aircraft operations. At the time of the incident, his flight career had barely begun. He had logged only 17 total flight hours, all on the Yak-18T. There was a third critical participant in this story, the Yak-18T aircraft itself. Built in March 2008, it was about 4.5 years old at the time of the accident. The plane had accumulated approximately 958 flight hours and completed 3,352 takeoffs and landings. According to the manufacturer's specifications, it was still well within its service life and capable of many more training flights. However, this particular aircraft had a troubling history. In several previous flights, other crews had repeatedly reported that its engine performance was unstable, with fluctuating RPM, especially during low-altitude operations. It seemed to be signaling distress. Yet these warnings were never taken seriously. The aircraft was not grounded for inspection, nor was the issue ever diagnosed or corrected. Notably, as early as September 2008, the principal of the Ulyanovsk Higher Civil Aviation School had sent an official and rare letter to the Yakolev Design Bureau, reporting operational problems with the Yak-18T model. The letter described how when using the Series 36 Yak-18T aircraft for student training, pilots had frequently observed a spontaneous longitudinal oscillation lasting 5 to 10 seconds, even when the throttle and propeller pitch controls remained unchanged. At that time, the cause was unknown. The document further recommended that additional tests be carried out to ensure the model's safety. This suggested that the Yak-18T had inherent design or structural flaws, and that the issue was already known at higher administrative levels. Yet, no effective action had been taken to address it. Thus, on that fateful training flight, the situation inside the cockpit was deeply unfavorable. An instructor with limited command experience, a student pilot with barely 7 hours of solo flight time, and an aircraft known to have unresolved mechanical defects. Together, they formed the first link in the chain of disaster.
November 7, 2012. Pitsenozhia Airfield, Ryazan Region, Russia. This small airfield had no paved runway and no fixed takeoff or landing direction. The surface was packed earth, roughly 1,400 by 1,300 meters in area. Flight direction was chosen according to the day's wind. Weather conditions that day were suitable for flying. Cloud base at 860 meters, visibility over 10 kilometers, wind from 230 degrees at 4 meters per second, with gusts up to 7, and a temperature of 7 degrees Celsius. That morning, the Yak-18T had departed from Sassovo Airport, flying to Pitsenozhia to perform a student training sortie. The mission was a standard takeoff and landing circuit exercise, known as a conveyor pattern. After each touchdown, the aircraft would not come to a complete stop, but immediately take off again, saving time and increasing training efficiency, allowing the student to practice multiple takeoff landing sequences in a single flight. At 14:37, it was student pilot Dmitry Fedorov's turn to fly. He successfully completed takeoff, climb, traffic pattern flight, landing, and retakeoff procedures, executing 3 complete circuits without incident. At 14:41, the crew began the 4th circuit. Throttle was advanced to full takeoff power, and the aircraft accelerated along the dirt runway. It lifted off smoothly. For the first few seconds, everything appeared normal. The climb was stable. At 14:41, at about 60 meters altitude and 170 kilometers per hour airspeed, the monitoring system recorded a brief rise in propeller RPM, followed by pronounced fluctuations. The engine became unstable. The steady hum turned to a harsh, uneven roar. This phenomenon is known as engine power instability, or RPM drift. Experts later identified the prime suspect, the governor, the component that regulates propeller pitch to maintain constant RPM. The investigation found several possible failure causes, but no single definitive one. First, internal inspection revealed microscopic damage inside the governor, scratches and scoring on the control valve, sleeve, and pressure reduction seat. Small defects capable of disturbing smooth operation. Second, the MS-20 oil used in the system did not fully meet national standards. If the oil's viscosity was too high or too low, the governor's response could become either sluggish or erratic. Third, investigators found a compatibility issue. The R2 series non-magnetic governor had never been approved for use with the AB-831 propeller. Each component worked fine individually, but together they could create instability. This combination lacked official certification and carried the risk of total system failure. Because these two systems work in close coordination, their mismatch was critical. The final report stated explicitly no single cause could be identified for the RPM instability. At 1441, the instructor radioed the flight controller requesting clearance for a reverse direction approach and landing. The aircraft turned right to enter the downwind leg for a return landing. It is almost certain that once the malfunction appeared, the instructor took over the controls. Later examination found injury marks on his left arm, the kind of muscle trauma typical of gripping the control stick tightly for a long time. The student arms showed no such injuries, indicating that the instructor indeed had control in the final phase. During the turn, the elevator was gradually pulled upward, a natural attempt to maintain altitude. But combined with the unstable engine power, this produced a dangerous sequence of brief climb followed by airspeed decay. At that moment, the aircraft was roughly 50 to 60 meters altitude, near landing speed, the point where a chain reaction began. The engine instability persisted, and the flight profile had become extremely precarious. In flight, an aircraft's bank angle directly affects its stall speed. The steeper the bank angle, the higher the stall speed. This is because, in a turn, additional lift is required to balance the centrifugal force. Thus, the wings reach their critical angle of attack sooner, and the stall occurs at a higher speed than in level flight. At 1441.38, with the airspeed around 160 kilometers per hour, the BAR's RM radio navigation recorder registered a stall warning signal. On the Yak-18T, this system illuminates a caution light when speed falls to within 10 to 20 kilometers per hour above stall, and activates both light and horn when within 5 to 10 kilometers per hour. But the records show that even after the warning, the crew took no action to reduce angle of attack. The elevator deflection remained excessive and continued increasing. The instructor kept pulling back on the stick, perhaps unaware of the consequences. To recover, they should have pushed the nose down, reducing angle of attack and gaining speed. But in that moment, they were under tremendous psychological pressure. The only engine was faltering, and they were at very low altitude. In normal operations, pilots are conditioned by habit. Pulling the stick means climb, pushing it means descent. Although both military and civil pilots receive stall recovery training, in sudden, extreme conditions, not everyone can apply that training instinctively. In moments of crisis, often habit overrides instruction. Between 1441 and 1441.38, the aircraft speed dropped to just 130 kilometers. During this interval, it entered a stall condition. The airflow over the wings broke down, lift collapsed, the airplane ceased to fly and began to fall. A stall during a turn is especially dangerous because in such moments, the airframe is under compound aerodynamic load. The aircraft had entered an extreme angle of attack regime. Its aerodynamic stability was completely lost. Throughout this stage, propeller RPM remained erratic. After the stall began, the aircraft likely rolled further to the right as the crew applied left aileron in an instinctive attempt to correct the bank, but control effectiveness was already gone. At 1441.43, the aircraft struck the ground nose first at a speed of about 160 kilometers, just 373 meters from the takeoff point. The impact was catastrophic. The nose section crumpled downward, the fuselage spine tore apart, and the cockpit structure was destroyed. The doors and surrounding components were heavily damaged, while the leading edges of the wings were crushed and deformed. The investigation. In the aftermath, investigators immediately began their work. Their findings showed that the direct cause of the accident was the crew's loss of airspeed control, leading the aircraft to exceed its critical angle of attack, stall, and crash. The underlying cause was the unstable operation of the power plant, most likely due to an imbalance between the engine propeller control system and the governor mechanism. Following the accident, authorities re-examined the nation's flight training safety system. They strengthened oversight of aircraft technical conditions and tightened pilot training requirements. All Yak-18T aircraft were temporarily grounded until every potential mechanical fault could be inspected and eliminated. Missed opportunities. The investigation committee also concluded that the instructor pilot could have significantly mitigated the outcome, perhaps even avoided the tragedy altogether. One clear finding stood out. The crew had fastened only their lap belts, even though the Yak-18T seats were equipped with shoulder harnesses. This detail once again highlighted the weak safety culture within the flight school at that time. Before the crash, there had already been reports of engine RPM fluctuations during earlier flights. Because of limited documentation, investigators could not determine whether the crew had noticed these anomalies. However, when the engine surges, it produces a distinct, loud roar, something that should have drawn attention. Yet the instructor did not order the aircraft grounded, and the training continued. Perhaps years of recurring but unresolved RPM fluctuations had caused habitual desensitization among pilots, a loss of sensitivity to potential danger. As the final report noted, the Sassovo Civil Aviation School, in organizing takeoff training at Pizhonojai Airfield, failed to account for the risk of single-engine failure. The area ahead of the runway offered no clear emergency landing space. Despite earlier evidence of power instability, the instructor disregarded the risk. Flight data analysis revealed that at takeoff power, engine RPM first rose to 103.2%, then dropped to 91.2% before periodically returning to normal. It was only 10 seconds after the first sign of engine abnormality that the instructor decided to return for landing. At the start of the turn, engine RPM was still about 95%, a level at which the aircraft could have maintained climb and regained speed. In simple terms, the crew lacked the experience and skill to manage sudden emergencies. Moreover, the Yak-18T's operating manual contained no specific emergency procedures for handling engine power instability, further worsening the chain of events.